one of the important thing that we are discussing about preambles. So we are discussing that okay, there are 64 preambles, okay, which is going to be used in the LT. So first of all, try to understand that what exactly you understand by the preamble. Okay, so this is one of the important question that comes in mind, that what exactly preamble means. So preamble you can consider a unique signature also. Okay, that there are 64 unique signature which your UV is gonna pick and try to send to the inode B as a message one. Okay, or you can say this, it will start synchronizing in the uplink direction by choosing that preamble. Okay, so if you, we can go with that particular example also. So first of all, try to understand there are 64 preambles being used as per the 3GPP in the LT. Okay, so preamble is a kind of signature, or if I'll take one example, let's suppose there is a door, or somebody has given a party, okay, and there is a door, okay, and he defined 64 kind of knocking pattern. Okay, and he invited, let's suppose, 200, 300 people, and he already designated that okay, there are 64 pattern which has been defined. So whoever will be coming, use any of the 64 knocking pattern. Let's suppose single knocking, double knocking, three times knocking, two times knocking, then wait, and then two times. Likewise, 64 knocking patterns. Let's suppose somebody has defined or entering into the party. Okay, the people are coming. That you can call it as person one, person two, person three, or you can consider it as a UV1, UV2, UV3. All are coming and knocking. Let's suppose it has chosen double knock. It has chosen triple knock. It has chosen same double knock also, because there are 64 it has defined. Okay, so multiple people can use the same knocking pattern also, because that is valid, which is defined by the organizer. This is what exactly, there are 64 preambles in a LT which can be used by the UV. So UV can pick any of the preamble and it can send message one. Okay, that we will discuss later. So this is what in general preamble definition is. And what exactly preamble look like, what exactly the structure of the preamble. So you can see preamble consists of CP, that is cyclic prefix, plus sequence. So if I am telling about cyclic prefix, so the understanding of the cyclic, yeah, so if I'm discussing about the cyclic prefix, the understanding of the cyclic prefix and why exactly it is going to be used. Cyclic prefix basically going to be used to mitigate the intersymbol interference. This is one of the major reason that we are using the cyclic prefix along with the sequence. So this is the structure of one preamble. So you can see the length can be designated at TCP and T sequence. TCP is the length for the CP and T sequence is the sequence length. So if you will add this, it is one preamble. TCP plus T sequence is the length of one preamble. Okay, now the question come in this particular context, that what exactly you have, or what exactly the significance of T, this capital T S. You can see here it is dot TS, that we will discuss. So first of all, the length of the cyclic prefix plus T sequence will gonna give you preamble length. So let's see. There are four type of preamble format in FDD. Okay, and preamble format 4 is for TDD. So you can see preamble format 0, preamble format 1, preamble format 2, preamble format 3 and 4. So CP, we have already mentioned cyclic prefix, okay, which can act like a guard interval to prevent ISI, okay, intersymbol interference. And then we are having the preamble sequence. So preamble sequence, we can call it as a key component for the RACH message, okay. So what you can say, it is a specifically designed sequence used for the UV identification and for the timing alignment. This particular sequence, okay. And there is one more term that is going to be used. We will see in the calculation, guard time. And why exactly guard time always added at the end of the preamble? Okay, there are multiple preambles at the end of the preamble so that it should not overlap, okay, between, let's suppose, multiple transmission is happening from the different use, so it should not overlap, there should not be confusion. That's the reason we are adding a guard time, okay. So there are, I have already mentioned that, you can see here there are four preamble format: 0, 1, 2 and 3, and based on that the length will change. So you can see for preamble format 0, what exactly the TCP length? 316.ts. Okay. And T sequence length 24576.ts. So this is, if you will add it, it will give you one complete preamble length when you are going to use a preamble format 0. One more important, you can say, aspect will come into the picture, that why exactly we are going with preamble format 0 generally in our regular deployment model. Okay, there we are having multiple, then why exactly requirement of multiple preamble format? So that answer we can get it from this particular calculation. Okay, and try to understand what exactly TS is. So TS generally refers your, what you can say, the basic time unit. Okay, so basic time unit, if you'll go with uh, formula, I'm not going much more depth, but if you go with formula, it will be uh, this particular seconds. Okay, so you can call it, it is the smallest time unit which is going to be used in the LT. Okay, and if you go a little bit more, so that, yeah, is basically derived from the sampling rate. And what exactly the sampling rate we are taking to derive this, that is 30.72 megahertz. This is the sampling rate if you are going to use in 20 megahertz of the system bandwidth. So this is what exactly the smallest unit of time being used, that is 1 by this much of second. Now if we are going to calculate, if we are going to use the preamble format 0, so what should be the radius of, from where exactly UV can pick the preamble and can send? Okay, so this is what exactly preamble format is going to define. So the maximum radius if you calculate, so you can see the preamble format 0, it is having the TCP length 3168. If, and if you are going to convert from this TS, that is the smallest unit, in ms, in millisecond, you are going to get 0.103 millisecond. Likewise, if you convert this T sequence into millisecond, it will be 0.80. So the total length, like TCP plus T sequence is your length of that preamble. So it is coming around 0.903. That is nothing which will be approx, we can consider as a 1, or 1 in a standard we can consider 1 millisecond if you consider in a frame subframe, so it will be one subframe. Okay, and the guard time that we are going to have 0.097, so that it should not, while doing the transmission, it should not interfere with the other. And while calculating the radius, so it will come around 14 kilometer. From 14 kilometer maximum the UV can pick and can send the preamble. So that is reasonable. Okay, that is the maximum. So we are in LT, we are having the node Bs at the distance of 1 kilometer, 1.5, 500 meter. So maximum, let's suppose if the other node Bs are not there or it is down, so UV can pick preamble maximum from the 14 kilometer. Okay, and see if you go with the other preamble format, it is 75 kilometer, 28, or not, which is practically in normal scenario. It's not required that your UV should peak the preamble from 75 kilometers or 28 kilometers. Then why exactly these preamble formats are being used? It is being used in such area, like suppose in huge forest or in a mountain area where there is a huge interference. There basically we are going to use this preamble format to mitigate the interference in that particular area. And let's suppose the E node B distance is too much high and too much more, okay, then we are going to use for. But in general scenario, generally we are going with the format 0. So this is what exactly about the preamble format and what exactly the preamble is.